bunch of social scientists begin studying social networks and begin struggling with the problem of nodes, people, and ties or edges that connect them. In fact, edge is the formal network term for the connection between two people on a graph, on a network graph. So they begin struggling with how to understand this phenomenon. And they develop a variety of ideas, a variety of statistical methods for studying social networks. But they were limited in large measure by the data. They didn't have data on large scale. And they were limited as well by the computational power that was then available to do some of the computations to understand networks. But they made a lot of progress. They invented a lot of techniques, and they really struggled with this and pushed the field about as forward as it can go. And then there was a kind of quiescent period for a while. The kind of heyday of social network studies initially was back in the 70s. And a lot of these methods were then, and these methods incidentally built on some efforts by very well-known Hungarian mathematicians who studied a branch of mathematics known as topology, which itself has an interesting and old history. And beginning in the 1990s, there was a kind of a resurrection of network science, initially by a group of physicists and mathematicians who were actually tackling problems typically in other domains. For instance, people interested in networks of genes or cellular networks, or people interested in networks of neurons. If we had a simple worm that is known to have 200 neurons, can we map all the connections between these 200 neurons and therefore understand how the worm learns or how the worm behaves? Can we understand learning and behavior not by studying the neurons, but by studying the interconnections between the neurons? So a whole bunch of scientists became interested in other kinds of networks. And they sort of bought or grabbed hold of a lot of these old sociological ideas. They developed the mathematics, they applied them in new ways, they tremendously improved the science of networks. And all of that intellectual architecture now is flowing back to the social sciences. It is being used by social scientists to sort of revisit and understand again a topic again that was of great concern to them and has been for quite some time. So we're at a moment when the methodology for the study of social networks has a leap forward has been made, building on past work. First point. Second point, we're at a moment when where people, given advances in telecommunications, where people are leaving digital traces of where they are, digital traces of who they're interacting with, digital traces of what they're saying or even thinking. And all of these types of data can be grabbed in a kind of, by the deployment of massive passive technologies. All this data can be grabbed and can be used to engage social science questions in a way that our predecessors could only dream of. We have vast amounts of data that can be reapplied to investigate fundamental questions about social organization and about morality and other concerns that have perplexed us for years. So we've had advances in methods, we've had advances in data, we've also had advances in ideas. People are beginning to think more creatively about what it means to have these kinds of higher order structures. And all of this is happening at a time in the late 1990s into the 00s where people are engaged, I think, in science more generally in what I would call the assembly project of modern science. So astronomers are beginning to think about how do you assemble stars into galaxies, and computer scientists are thinking about how you assemble computers into networks, right? We have the discovery or the development of the internet in the mid-1990s, so everybody is beginning to think about, well, there are all these computers and they're on a network and they're interacting with each other and so forth. So engineers are struggling with this problem. Neuroscientists are beginning to think about, okay, well, we've understood all the neurons, we understand a lot about neurons, how do they interconnect? Or geneticists are saying, well, right, at the end of the day, we're going to have understood all 25,000 approximately human genes, and then what? You know, how do we put Humpty Dumpty back together? How do we reassemble all these genes and understand how they interact with each other in space and across time? So this, and this sort of, we've seen the birth of a new field in biology called systems biology, which seeks to put the parts back together. And similarly, in social science, there is increasing interest in the same similar kind of phenomena. Okay, we've begun to understand human behavior. We have had models of rational decision-making, which have then led to other innovations, sort of that question the rational actor models. But these models all pertain primarily to individuals. Of course, Adam Smith talks about markets as as a phenomena that emerges from the action of individuals. But nevertheless, we've been primarily focused on the actions of individuals. How do we put all these parts back together and understand groups? And again, the study of social networks is part of this assembly project, part of this effort to then understand how you can have the emergence of order and the emergence of new phenomena that do not inhere in the individuals. So we have, for example, consciousness, which cannot be understood by studying neurons. Consciousness is an emergent property of neuronal tissue. And we can imagine similarly certain kinds of emergent properties of social networks that do not inhere in the individuals. Properties that arise because of the ties between the individuals, because of the complexity of those ties. And understanding all of that is what drives me and James Fowler to death right now. So we're obsessed with trying to understand this.